So good day everyone. We will now be discussing the first topic under module 2, which is about vectors in R raised to n. For our objectives, we're going to represent a vector as a directed line segment, perform basic vector operations in R squared, and represent them graphically. Perform basic operations in R raised to n. Write a vector as a linear combination of other vectors. Let us first consider vectors in a plane. Vectors in a plane. Geometrically, a vector in a plane, so when you say vector in a plane, you're going to have your x and y axis. So a vector in the plane is represented by a directed line segment with its initial position coming from the origin and its terminal point x1, x2 as shown below. So you start with the initial position at the origin 0, 0, and you have your terminal point x sub 1, x sub 2. The same ordered pair used to represent its terminal point also represents the vector. That is, the vector x equal to x1, comma, x2. The coordinates x1 and x2 are the components of the vector x. Two vectors in the plane u equal to u1, u2 and v equal to v1, v2 are equal if and only if u1 is equal to v1 and u2 is equal to v2. So we say that two vectors are equal if their corresponding elements are equal. To represent u, which is equal to 2, 3, draw a directed line segment coming from the origin to the point 2, 3. So when you have the vector u composed of the elements 2, 3, the initial point is the origin, and you have the terminal point at x is equal to 2, and the second coordinate is 3. So this is your vector. To represent the vector v equal to negative 1, 2, so x component is negative 1, while the y component would be positive 2. So we draw a directed line segment from the origin to the point negative 1, 2 as shown in the figure. Vector operations. There would be different operations that we will be performing with respect to vectors. We have the vector addition and scalar multiplication. So first, let us consider vector addition. So if this involves two vectors, we can add these two vectors. So to add two vectors in a plane, we're going to add the corresponding components. That is, the sum of u and v is the vector u plus v equal to u1, u2 plus v1, v2. So u1, u2 plus v1, v2. What we are going to do is to add their corresponding components. u1 plus v1 and then u2 plus v2. Thus, the resultant of these two vectors is u1 plus v1, comma, u2 plus v2. Geometrically, the sum of two vectors in the plane can be represented by the diagonal of a parallelogram having u and v as its adjacent sides, as shown in the figure. So if this is the vector u and this is the vector v, so we create a parallelogram, and the diagonal coming from the origin would serve as the resultant of these two vectors. Examples. Find each vector sum u plus v. So take note that we're going to add corresponding components. So 1 plus 2 equals 3. 4 plus negative 2 is equal to 2. So thus, the result is 3, 2. If we will be adding 3, negative 2, to negative 3, 2, it would be 0, 0. So we have the 0 vector. All components are 0. Similarly, if we're going to add 2, 1 to 0, 0, so 2, 1 plus 0, 0 is 2, 1. So we can say that 0, 0 is the identity element. So this is the vector that we add so that the result would just be itself. While negative 3, 2 is the inverse, the additive inverse of 3, negative 2, because that is the vector that we add that would give us the 0 vector. These are the graphical representation of the sum of two vectors. So for this one, the result is 0. We can say that V1 is equilibrant. This is the vector that we're going to add to the second vector so that the sum is 0. While this one is the identity, it does not change the given vector, the original vector. So first operation is vector addition. The second one is scalar multiplication. For scalar multiplication, we are going to multiply a vector v by the scalar c. So take note that the vector v is multiplied to the scalar c. That is, cv is equal to c1 v1 comma c2 v2. So we multiply each component by the constant. So let us consider multiplying the vector negative 2, 5 by 1/2. So that means we're going to have 1/2 times negative 2 and 1/2 times 5. So that would give us negative 1, 5 over 2. Now, if we are going to solve for u minus v, it is the same as u plus negative 1 times v. So we multiply v by negative 1. So that would be 2, negative 5. And we add it to u. So that's 3, 4. So 3, 4. And then negative of negative 2 and then minus 5. So that would be 5, negative 1. And lastly, if we want to solve for 1/2 v plus u, so first we multiply v by 1/2. So this is the result from letter A. And then we add v. So we add 3, 4. So negative 1 plus 3 is 2. And 5 over 2 plus 4. So you may use your calculator for this. It would be 13 over 2. So this is the graphical representation of all the things that we have just computed.